The objective for Lesson 5 is to connect visual models and the distributive property to partial products of the standard algorithm without renaming. Question 1A says draw an area model and solve using standard algorithm. Use arrows to match the partial products from the area model to the partial products in the algorithm. Now during the preview I showed you a partial products where you broke it down by each place value. This time I'm going to show you how to do an area model, which is a lot easier when it comes to the multiplication than the partial products. Now here we have 24 times 21. Instead of splitting 24 up by place value, I'm going to leave 24 whole on top. Now my second factor, 21, I'm actually going to break it up to 20 and 1. Now when I find my individual two products, I have 1 times 24 is 24. The second one is 24 times 20. And what we've done before is 2 times 24 is going to give us 48. And then we have to add the 0, so we know it's 480. Now when you add these two together, 480, 24, you get 504. So we know 24 times 21 is 504. Now let's go to standard algorithm. Let's see how this matches the area model. The first one we would do in the standard algorithm, we would go 1 times 4. And then we would do 1 times the 2. So in all actuality, this right here, this first one was actually 1 times 24, which is the same as what we had on the bottom of our area model. For the second one, since we're done with the 1, we're actually going to be multiplying by the 2 or 20. But instead of multiplying by 20, we're going to put a placeholder down here. So now we're going to be multiplying by 2 instead of by 20. And we go 2 times 4 is 8. 2 times 2 is 4. Now if you notice 480, up here we have our 20 times 24, and that's our 480. We add them together, 4, 8 and 2 is 10, carry our 1 and 5. And you can see we have the same answer. Solve using the standard algorithm. So this time we're going to solve using the standard algorithm. We're not going to draw the area model. Now if you need to check yourself, it's always a good idea to check yourself using either another strategy or the reverse operation. Now we're multiplying 314 times 22. We're going to start off, we actually have 2 times 314, but I'm going to do one digit at a time. 2 times 4 is 8, 2 times 1 is 2, 2 times 3 is 6. So I know 314 times 2 is 628. Now we're going to do 20 times 314, but I'm going to put a 0 down here, so once again I can just do 2 times 314. And 2 times 4 is going to be 8, 2 times 1 is 2, 2 times 3 is 6. When we add our two partial products together, we end up with 6,908. Now if I wanted to check myself, I could do the area model, or I could also do a division problem. So I'm going to do a division on this one just to check it. So if I have 6,908 and I divide this by 22, I should come up with 314. Well, I know 22 cannot go into 6, but 22 can go into 69 3 times, because 3 times 22 would be 66. I'm going to subtract what I used, and I have a remainder of 3. When I regroup them to hundreds, I would end up with 30 hundreds. Now I know 22 would go into 30 hundreds one time. 1 times 22, because I have to subtract the hundreds that I've used, I end up with 8. When I regroup 8 tens, I would end up with 88 ones. 22 would go into 88 4 times. 4 times 22 is 88. And we come up with 0. So you can see I've double checked myself using the reverse operation. Now in C, we have 213 times 32. We know 2 times 3 is 6, 2 times 1 is 2, 2 times 2 is 4. Because we've actually done 213 times 2 is 426. Now our second part is actually 30 times 213. But we're going to put that 0 out of here first, so we're only going to be multiplying by 3. And we go 3 times 3 is 9, 3 times 1 is 3, 3 times 2 is 6, and we have 6, 9 and 2 is 1 is 11, 3 and 4 is 7, 1 is 8, and 6,816. Now on this one, instead of doing reverse operation, I'm going to go ahead and do the area model. And I'm going to split it up between 30 and 2. And on top, I'm putting 213. Now, one thing I like about double checking myself using the area model is I can verify each one of these partial products and my answer. So I know 2 times 213, 2 times 3 is 6, 2 times 1 is 2, 2 times 2 is 4. So 426, that checked. 30 times 213, I'm going to put my 0 in here, so I'm only dealing with 3. 3 times 3 is 9, 3 times 1 is 3, 3 times 2 is 6. So I have 6,390. That checked. When I added them both together, I have 6,816. That checked. So I was able not only just to check the answer, I was able to check my individual partial products in case I made a mistake on one of them. Question 3 is a word problem. It says a young snake measures 2,300 meters long. During the course of his lifetime, he will grow to be 13 times his current length. What is the length what will his length be when he is fully grown? Okay, so here it says, I'm going to draw a tape diagram so I can see it. And I can see it says that he is 2,300ths of a meter long. And it says he will grow to be 13 times that. So I know that this is going to be 13 times. And the top of my tape diagram is going to show total length. And I can see with this, I'm going to end up with 13 times 2,300ths. All right. Well, first thing I'm going to do, if I wanted to use my area model, or if I wanted to use my standard algorithm, is I would have to get rid of this decimal. Now, we like to say we take out the decimal, but in all actuality, what we're doing, we want it to move 2 place values, so we would multiply it by 100 to get it to be 23. So now we have 13 times 23. 3 times 3 is 9. 3 times 1 is 3. Now we're going to go with 20, but we're going to put the 0 down here, so we're not doing 20. We have 2 times 3 is 6. 2 times 1 is 2. We add them together, we have 9, 9, 2. But now we have to put the decimal back in. We multiplied by 100 to remove the decimal, so now we have to divide by 100 to put it back. And if I divide by 100, I know the number's going to get smaller, so my decimal point's going to move 2 places to the left, and it's going to be 2 and 99 hundredths. Now, if I wanted to double check myself on this one, I know I have 13. I could also do a couple different ways. I could do the area model again, and I'm going to put 23 on top. I'm going to split it up with 10 and 3 because I know my 10s very well. Now, I know 3 times 26 is going to be 69. 10 times 230 is going to be 230. When I add them together, I get 299. But it was actually 2,300ths. So this is actually 2,300ths times 13. So this is going to be 299 hundredths. THS. So with 299 hundredths, in order to be hundredths, I'd have to have it the last digit in the hundreds place, so that means I would have to put my decimal here.